Hello, my name is Lacer Garcia, and I'm a distance learning student at Florida State University for their computer science degree. I am located in Miami, Florida, and I have been back at school for about 5 years now, after about a 12-year hiatus. I've been working for the past 16 years at a logistics company in a number of roles, starting from data entry clerk all the way through management, and in my latest role, which is sort of trending towards where I want to be, as a systems and process specialist. I deal with business implementations from an IT perspective in this new role. For my topic today, I will be discussing the make utility and some of its capabilities. The make utility by Lacer Garcia for COP4020. Generally speaking, good programming focuses on generic programming and reusability, but inherent to those two practices is separating code into multiple smaller files that allow for portability and reusability. This causes an issue, or I should say it was causing an issue, when it came to understanding if newer files that had been debugged had been compiled or not, causing hours of unnecessary work. This laborious process gave way to the idea of make. We'll take a look at some of its history, functionality, and features in the next few slides. So the problem many programmers were facing in the late 70s was the hours they were spending debugging files that they had already corrected. When multiple people were working on different source code files, and with so many moving parts, it was difficult to tell if a file had already been recompiled. And this was causing many issues. This gave way to the idea of make. It was not an issue for smaller projects, but for larger projects, it was causing an issue. Another issue that make attempted to solve was unnecessary recompilations by using the last modified date. There was no need to recompile the entire file if you only needed to recompile a few of them. And also this enhanced a program's portability, because if you can now split your code into multiple separate files, now it's easier to know if it's been debugged before you implement. Problems discussed on the previous slide are at the root of the origin for the make utility. Once again, the hours of needless debugging is what led Stuart Feldman at Bell Labs to develop make in 1976. The dependency tracking is now common practice for practically all integrated development systems in use today. However, that wasn't the case in the mid 70s, and programmers often struggled with understanding when a compiled program had been updated with the latest source code updates. It began with an elaborate idea of a dependency analyzer, boiled down to something much simpler, and turned into make that weekend, said Feldman. Stuart Feldman began with a problem he and his colleagues faced daily and turned it into a widely used solution over a weekend in that same April 1976. The foundation of the make utility is a file called the make file, and it's just a simple text file. By default, invoking the make command within the project directory will trigger the search for a file named makefile. Of course, makefile is not the only name that can be used, as the file name make searches for can be selected by invoking a -f modifier. We'll discuss that in a later slide. Within makefile, rules govern how make will build your program. A rule explains how and when to remake certain files, which are the targets of a particular rule. The makefile also allows for the use of variables to assign the name of source code files or object files, directories, or even values to be used multiple times within the document. Another function that make supports via the makefile are Linux commands. One example of that would be the clean command that can be used to delete old object code files that have been created inside the directory. As mentioned before, what governs the makefile are rules. Rules appear in a makefile and provide the recipe needed to create and remake a file. The file being created or remade is known as the target, with the top rule or target listed in the file being the end goal of the entire makefile. The recipe is usually in the form of a Linux command that will execute when make is invoked. Usually the makefile is written so that the first rule is the one for compiling the entire program or all programs described by the makefile. Recipes are great because they allow you to determine compiler rules and specific warning flags you may want to invoke to show you information regarding any errors. However, they aren't necessary when compiling individual C source code files because make has an implicit rule for updating a .o file from a correspondingly named .c file. Make supports the use of wildcards for file names in the recipe or command portion of the rule. If your target requires the use of all files ending in C within the directory, you could use an *.c and it will pull all files of that name. In order for a target to compile properly, its dependencies must also be updated. There is a relationship created between targets and dependencies that is determined by the operator used to separate them. Dependency lines consist of one or more targets, an operator, and 0 or more sources. The last modified date is key in determining when a source code file needs to be recompiled. This is one of the key aspects that defines make and why it was developed in the first place. The ability to manage larger projects and determine if programs containing multiple sources needed to be recompiled was integral to its initial functionality. Make also supports a number of advanced features that add more functionality to its core set of uses. There are too many to name them all, but we'll get into a few. It supports the use of functions, much in the same way they are used in C. Functions allow you to perform text processing in the makefile, to compute the files, to operate on, or commands to use in recipe. A function call in a makefile works very similarly to how you would call an already initiated variable. By typing out a $sign and open parentheses, the function, the arguments, and a close parentheses. Another advanced feature is the use of conditionals. Conditionals cause part of the makefile to be obeyed or ignored depending on the values of the variables. This allows for the use of variables within the body of your makefile, with the ability to change and mold the values of the variable, and the makefile would take on different commands as a result. One example would be the use of ifdef, which tests if a variable contains a value. If it does, it processes the command that is immediately following. If not, it processes a command following an else statement, similar to how it would work in C. This enhances the makefile itself's portability, because the programmer could use the variables to create scenarios that work for multiple programs. Another advanced feature that can be taken advantage of is through assignment operators. There are 5 different assignment operators that can be used with varying degrees of functionality, and I'll walk through some of them with you. The equal sign assigns a value to a variable, simple enough. The plus equal signs appends a value to a variable. The question mark equal sign assigns a value only if a value has not already been assigned. So it's a conditional assignment. A colon equal sign assigns a value after it has been expanded, and it's used when you're assigning one variable to another. And an exclamation point equal sign is used to expand the value, pass it to the shell, and then get the return value assigned to the variable in question. Finally, the last set of advanced features that I would like to discuss are flags. Flags are invoked when make is executed in shell. and they offer an array of functionality, ranging from debugging to changing the name of the makefile to directory management. And I'll go through some of them with you. -C changes the directory before reading the makefile. -D will put you into debugging mode. As mentioned earlier in the presentation, -F will allow you to specify the name of the makefile, and it's invoked by typing out make-F and the makefile name. -I will allow you to -I, I should say, will allow you to specify the directory where the makefile is located. -S will instruct make to not echo commands as they're executed. And finally, a -W will treat any warning as an error. And finally, to conclude our presentation, the make utility is a powerful tool that, when properly used, can make the software development experience seamless. It can manage multiple sources through its dependency lists, functions, conditionals, special assignments, flags, and much more. Through the use of these tools, it can make the maintenance and compilation process as dynamic as the software it's being used to manage. In addition to this, it allows for large teams to work on programs' separate source code files simultaneously with its built-in dependency management capabilities. What started as a small idea has become an integral part of the programming experience.